All right, so we're beginning to look at unit circle trig. So the first thing is, let's remind ourselves what a circle equation is. So if we had the equation x squared plus y squared equals 1, we should know from previous years that that circle has a center of 0, 0, and circle equations are always equal to r squared. So this circle has a radius of 1 unit. And so using that information, we can start to label some of the points around the circle. So I'm going to label these points around the circle, but first I want to put in all the common angles that we already know, that we've had on speed quizzes and regular quizzes previously. So take a minute to fill in all of these degrees. One thing I want to point out, I write these degrees up here not to say that this is 30 degrees. I'm saying that this is 30 degrees, this is 45 degrees, this is 60 degrees, etc. We just don't have room to write all of that all the way around the circle. It would get really cluttered if we wrote the angles down here. So I had to clear that up in class the other day. So these are all angles in their standard position. 150 degrees is this angle right here. Okay, so labeling all of these in degrees. When we have speed quizzes, we will be given angles in both degrees or radians. And our AP test is exclusively radians, but I think it's important, especially since you guys use degrees in physics, to be familiar with both. All right, so those are all of the degrees, all of the radians. Again, we should know these pretty well. We used the counting. We should know them pretty well. It'd be helpful if I wrote them correctly. We used the counting method to write these down when we had a speed quiz on them. It will be good to start picking up on patterns as well. Like if you take a look at these quadrant 2 angles, all of the numerators are 1 less than the denominator. If you look at the quadrant 3 angles, all of these have a numerator that's 1 unit larger than the denominator. And there's not as nice of a pattern. There is a pattern. There's not as nice of a pattern, so let me write these down first. And I'll talk about this pattern. Because quadrant 4 is almost 2 pi, for each of these numerators, you double the denominator to make 2 pi, so 6 pi, and then you subtract 1 from the top. So 5 pi over 3. So it's like we go 2 pi, but then we go back a pi over 3. We go 2 pi, go back a pi over 4. So whether you just remember those or you pick up on the patterns, it will be helpful to have a few different ways to remember these angles as we are starting to add trig to this. Okay, so we labeled all of the common angles. And the other thing I want to do is label where the circle has x and y intercepts, meaning let's go ahead and write what these points would be. Remember, this is 0, 0, and the radius is equal to 1 on this circle. So this point over here is the point 1, 0, because it's just 1 unit to the right of 0, 0. And this unit up here, again, r is 1, so 1 unit above 0, 0, 1 unit to the left of 0, 0, and 1 unit below 0, 0. So those are the first 4 points around our around our unit circle. We're going to work on filling in the rest of the ordered pairs, and then I'll talk about how we're going to use this circle with all of its angles and all of its ordered pairs on the next page. All right, so step 2 says label the side of this triangle with r equals 1 as the hypotenuse and theta equals pi over 6. I want that to go right here. Find x and y. What I'm emulating with this is this triangle. Imagine that this is the point in the center of the circle right here. And we're talking about pi over 6. Remember, pi over 6 is really this angle right here. What we're saying is if we could drop in a right triangle, how far over to the right and how far up do I have to go to get to that point on the circle? So let's label x and y. We're trying to figure out this ordered pair on the circle, which would be xy. All right, so to do that, this is a 30, 60, 90, so we could go back to our geometry days and figure out what x and y are. But we can also use trigonometry to figure that out. So x is adjacent to this angle, so I can say the cosine of the angle is equal to x over 1, adjacent over hypotenuse. And so really x is just equal to the cosine of pi over 6. Now, how do I figure out the cosine of pi over 6? Let's draw our special right triangle. Pi over 6, remember, is 30 degrees. So the leg opposite 30 is 1. The other leg is radical 3. And 2 is the hypotenuse. So the cosine of pi over 6, adjacent over hypotenuse, is radical 3 over 2. So this gives me the x-coordinate right here. Now I know from 0, 0, this point on the circle is at radical 3 over 2. That's how far to the right we have to go. And then how far up do we have to go? Well, I can work on this triangle again and say the y-coordinate is opposite of the angle. So I can set up a sine of pi over 6 equation. It's equal to y over 1. So the sine of pi over 6 is just equal to y. And if I use my triangle again, pi over 6, opposite of that is 1, hypotenuse is 2. So the y-coordinate is 1/2. So at this ordered pair, to get from 0, 0 over to this ordered pair on the circle, we would need to go right radical 3 over 2 and up 1/2 unit. Now, we don't have to do this, draw a triangle for every single angle on here. This is a circle. So these pi over 6 point angles on the circle, the points that go with them, they're symmetric. So I can just say this point over here at 5 pi over 6 should be almost the same point, except it's negative radical 3 over 2, positive 1/2. And down here at 7 pi over 6, if you reflect that across the x-axis, the x-coordinate's still negative in quadrant 3, and the y-coordinate's also negative in quadrant 3. And finally, at 11 pi over 6, the x-coordinate is positive over here because you're to the right of 0, 0, but you're down below the x-axis, so negative 1/2. So we did some trig to figure out the first pi over 6 angle, and then we knew the others just by working with symmetry and knowing about points in each quadrant. So let's do that again for pi over 4, pi over 3. So now we have this rule for finding those ordered pairs. Remember, x came out to the cosine of pi over 6, and y was the sine of pi over 6. And all I would do to this triangle is change out the angle down here. It could be pi over 4, pi over 3. So instead of drawing this triangle every time, we can say x will always just be, the x-coordinate will always just be the cosine of theta, whatever angle you're talking about. And the y-coordinate will always be the sine of theta at whatever angle you're talking about. So if I would like to fill in for pi over 4, I can say, well, the x-coordinate at the pi over 4 angle should just be the cosine of pi over 4. And we can figure out cosine of pi over 4. Let's draw that right triangle. That's the 45, 45, 90. It's got two legs of 1 and hypotenuse radical 2. So the cosine of pi over 4 is 1 over radical 2. And remember, we always rationalize our answers. So the x-coordinate is radical 2 over 2. And the y-coordinate should be the sine of pi over 4, which is actually the same thing, right? Opposite over hypotenuse is still 1 over radical 2. So y is also going to rationalize to radical 2 over 2. So let's put that ordered pair right here on the pi over 4 angle. So radical 2 over 2 for x and for y. That's kind of easy to remember. And then just like I did with my pi over 6 angles, I can reflect this around the circle and just make small adjustments with negative signs. In quadrant 2, it's negative radical 2 over 2, positive radical 2 over 2. In quadrant 3, they're both negative radical 2 over 2's. And in quadrant 4, positive radical 2 over 2, negative radical 2 over 2. And finally, for pi over 3. for pi over 3, x equals the cosine of pi over 3. Now, pi over 3 is just the other angle in your 30, 60, 90, right? That's the 60. So pi over 3 is down here. I'm just going to use the triangle I used from the previous problem. So cosine of pi over 3 is 1/2. And the sine of pi over 3, the sine of pi over 3 is radical 3 over 2. So for the pi over 3 angle, or the 60-degree angle, this ordered pair is 1/2 radical 3 over 2. And notice that that is just the 30-degree coordinate, but flipped. So they have that relationship. All right, so let's rotate this around our circle. So now negative 1/2, positive radical 3 over 2. So in quadrant 2, all the x's are negative, all the y's are positive. In quadrant 3, both x and y are negative. Negative 1/2, negative radical 3 over 2. And in quadrant 4, all the x's are positive and all the y's are negative. All right, so as far as do we have to memorize the whole unit circle, you definitely need to know quadrant 1 really well, what these three ordered pairs are and the correct order of the radians and degrees. And then you should be able to use your knowledge to then kind of go around and maybe fill in parts of the other unit circle. But I would never, for a speed quiz, I would never write out this entire unit circle because it can take time out of your speed quiz to do. We'll talk about speed quiz strategy and stuff next week. So how are we going to use this thing? In our previous two sections, 4.1 and 4.3, we were looking at right triangle trig. So everything was from a right triangle perspective. And that meant that every time we did sine, we did opposite over hypotenuse. We were doing SOHCAHTOA, TOA, figuring out what's opposite, what's adjacent, drawing triangles every single time. So now in 4.2, we're looking at things at trig from a unit circle perspective. So instead of always drawing the triangle, I know I drew some to get this started, but we're going to start with a unit circle. And so instead of always drawing triangles, we're going to be looking at the xy ordered pairs and the fact that the radius is equal to 1. And that's going to help us also figure out what sine, cosine, and tangent are equal to. Everything is based on the unit circle, which used special right triangles. That means that this whole section would be no calculator. All right. So in terms of x, y, and r equals 1, write the 6 trig functions of any angle around the unit circle. So remember, sine of theta back here, we had a rule. Sine of theta was always equal to the y coordinate on the unit circle. So sorry, not sure what happened there. Okay, so that meant that sine of theta here should always equal the y coordinate on the unit circle. We can use that same rule. And cosine was always equal to the x coordinate on the unit circle. Tangent we didn't have to use to create this unit circle. So let's go back to this triangle here, the one that was represented from the center of the unit circle. If I said, what's the tangent of pi over 6? Opposite over adjacent would lead you to y over x. So that's our formula for tangent. Instead of drawing a triangle, I will just look at the y coordinate and divide it by the x coordinate. Now the reciprocal functions are still reciprocals. So cosecant is the reciprocal of y, secant is the reciprocal of x, and cotangent is the reciprocal of tangent. So I'm just going to show you how to evaluate trig functions. Instead of drawing triangles, we can now use any angles more than just the ones that are in quadrant 1, which is what we've been doing. Now we can look at any angle around the unit circle and figure out the sine, cosine, or tangent. So the way that I do this is first determine whether you should be using x or y over x, or whatever the trig function is. So decide which of these 6 rules you're using depending on what trig function it is. And then the second thing is to find your angle, meaning locate it on the unit circle. And the third step is to simplify if needed, like rationalize denominators, or tangent and cotangent require a little bit of division to happen. So this is sine, which means I should be looking at the y coordinate. I go to pi over 6, I look at the y coordinate, That's my answer, 1/2. This one is tangent, so I should be looking at y divided by x. Go to pi over 4. Here's y, radical 2 over 2. Here's x, also radical 2 over 2. So don't do a bunch of math on this. A number divided by itself is 1. Cosine is equal to x. Go to pi, find the x coordinate. The answer is -1. So I couldn't have given you this last section because pi does not fit in a right triangle. So that's kind of the benefit of unit circle trig. Cosecant is the reciprocal of sine, so 1 over y. Now, even though I write 1 over y, I'm just thinking reciprocal. So go to pi over 3. Take a look at the y value, radical 3 over 2. So don't do 1 over radical 3 over 2. Just flip radical 3 over 2. You get 2 over radical 3, and then rationalize that. 2 radical 3 over 3. Tangent is y over x. Go up to pi over 2. Y is 1. X is 0. Now, anytime we divide by 0, that's undefined. So we're just going to write no solution for this. Tangent of pi over 2 is not possible, or it doesn't exist. It's possible to get answers like that for tangent, cotangent, or any of the reciprocals because you have that division piece. Sine is equal to y. Go to 5 pi over 6. Take a look at the y coordinate. The answer is 1/2. Secant goes with cosine. It's the reciprocal of cosine. So 1 over x. Go down to 3 pi over 2. X is 0, so 1 over 0 is undefined. So again, we get undefined. Cotangent is x over y. I remember that because tangent is y over x. Cotangent is x over y. What's on top is alphabetical. So like cotangent comes before tangent, x comes before y. Anyway, go to 4 pi over 3, x over y. Now, the long way to do this is to make it -1/2 over negative radical 3 over 2. And then when we divide by fractions, we multiply by reciprocals. The 2's are going to cancel. We've got to simplify from there. But I say that's the long way because you really didn't need to write this step or this step. You could get right down to this because if you know in all of these fractions, look around the unit circle, all of the fraction answers are over 2. So every time you do x divided by y or y divided by x, the 2's will cancel. So I just look at the numerators and I would just write down -1 over negative radical 3, and then we've got to simplify that further. It's positive and rationalize its radical 3 over 3. All right, cosine is x. We're looking at 11 pi over 6. The x coordinate there is radical 3 over 2. Now, these last 3 angles are not unit circle angles, but they are coterminal to unit circle angles. So we need to figure out where do you land in our unit circle if you rotate negative pi over 3. So negative pi over 3 is this far, right? Negative 60 degrees. You land at 5 pi over 3. So the tangent of negative pi over 3, if you do, you're at that coordinate, if you do y over x, is the same as the tangent of 5 pi over 3. So I'm doing y over x. Just look at the numerators. Y is negative radical 3, and x is 1. Simplify, and that's the final. Where does 5 pi over 2 get you? Remember, that's 2.5 pi. It's easier if you switch to a mixed number for that. Well, 2 pi is a full circle, and then an extra half pi lands you up here at pi over 2. So this is the same as the sine of pi over 2. Take a look at the y coordinate at pi over 2. The answer is 1. Last one, negative 3 pi over 2. Negative 3 pi over 2. Negative 1 pi is here. Another negative half pi is here. So that also lands you at pi over 2. So this is the same as the cosecant of pi over 2. That's 1 over y. Remember, the y coordinate was 1. So 1 over 1 is 1. That's it for the unit circle video. Please come into office hours if you have any questions.